For our digital logic design final project, we made a logic game about logic. Our goal was this: utilizing concepts we learned from this logic class, take advantage of Verilog and FPGA, make an original game that is about this class and is actually fun to play with. So, Algal is born. Hold on. Ad break.
Are you tired of your miserable engineering college kid complaining about how difficult their logic design class is and use it as an excuse to keep asking you for more allowance? Well, look no further than Algal, a fun and engaging game that aims to help them review the core concepts of logic design, the logic gates. Not only does it provide a cute and interactive interface to allow them to stretch their logic gate knowledge muscle, but the colorful graphic is sure to engage those phone-addicted, short attention span, miserable young adults. Only $4.99 and you can get the full package that lasts a lifetime, making the perfect gift for Christmas.
So, the game setting is this. The player character is a penguin that gets trapped in a logic universe where he gotta defeat the enemy, which are the logic gates. The player's weapon is a gun that shoots bullets, which are binary numbers, zeros and ones, and in order to defeat the monsters, you need to feed in the correct logic input given the output. This is what's happening behind the scene. The code can be basically separated into three parts: the player controller in Verilog, data transmission with UART, and the game environment with Python. The player movement is controlled by two buttons on the FPGA board, BTN-U and BTN-D. Player can fire bullets with the BTN-R button, and switch the ammo between 0 and 1 with the natural switch, and to reset the game with the BTN-L button. In Verilog, for player movement, we implement a state machine that, based on clean button inputs with debouncers, changes the player location by lanes. The screen is divided into 6 lanes, which are 6 possible locations for the player to reach. The lane data is concatenated into 4 bits of data. We also allocated 2 bits for the firing of the bullet. One for the type of the bullet, and the other is high if firing is detected, and another bit for when the reset button is triggered to restart the game. These data is transmitted via UART, a protocol for sending serial data between 2 devices. We implemented a special clock divider to send data at the correct baud rate, as well as transmitter and controller modules to correctly manage the idle, start, data, and stop states of the transmission process. On the host computer, we then use Python to parse the data. The rest of the game logic is also implemented in Python, including projectile collision detection, the enemy logic, and enemy spawning. Something to point out that we implemented is that the enemy is randomly selected and dynamically generated with the location matrix, and the levels have progressive difficulty, so as the level increases, there will be more enemies spawned per level, and they will progressively travel faster, making the game more difficult. Thank you for taking the time to learn about our project, and I hope you enjoyed a logic game about logic.